Hey, this is Brent Salisbury. In this section, we're going to go over virtual switches. I want to take a little bit of a data center focus, but I don't want to get into topics such as OpenStack just because it's kind of beyond the scope of this, and data center orchestration as a whole is pretty tough. So we're just going to kind of talk about the basics of virtual switches. So there's more virtual ports than there are physical ports in the world today. Quite overwhelmingly more, and growing. So, in order to do that, in order to have, the main reason is physical servers being consolidated into virtual servers. So, we're probably still, not quite at the 50% mark. So that's going to continue to grow. So the nice thing for us in networking is there's more flexibility in the software switch than there is in the hardware switch today. So if you take your average, something like Open vSwitch, which we'll be talking about today in the lab, is going to focus on Open vSwitch. You can do about 1,000,000 flow rules, and probably more. So there's probably ways to scale that a little bit more. But your only limitation is, processor and memory. So 32 cores and gigs and gigs of memory versus your average Trident, let's say Trident Broadcom based chipset. So at 10 and 40 gig, you're around 750 flows. At 1 gig to 10 gig, you're around 3,000. And so the reason is because TCAM has to be partitioned, and so there's parallel lookups, and you're just significantly limited. Because it's being done in silicon as opposed to strict silicon that wasn't necessarily made to forward all packets, just access lists and things like that. So as you have these virtual machines, they're going to attach to virtual ports. So here we have 2 virtual ports attached to one NIC or multiple NICs. You can plumb a VM. Let's say you had 4 VMs and 4 NICs on a server. You could easily plumb all of those NICs one-to-one. So each NIC has its own, or each vNIC, virtual NIC, or virtual interface where the virtual machine connects to that NIC is a one-to-one mapping, or you can have it share them. So you have all the ability you have in physical switches today. So you can put VLANs into these. You can put link aggregation groups. So trunking, so we can put multiple VLAN tags down to a server, or multiple down to a VM, or multiple VM VLAN tags into the native LAN, whatever. So I mean, just kind of assume you have almost parity on features, and then whatever you don't, you can always just program. So you can programmatically, since you're sitting on Linux, that opens up a whole kind of realm of what you can do to provision this, as opposed to logging into a CLI and provisioning ports and plumbing VLANs. So you don't necessarily have to use, let's see, sorry, I spilled the water on this. There we go. So there are NICs that can bypass that kernel. So the important thing of something like Open vSwitch is it's upstreamed into the kernel. So by being upstreamed into the kernel, it's attaching to the same resources as Linux bridging was. So it basically replaces it, or it does replace it. But there are NICs. Intel has VIO or whatever it is, but it's basically saying, well, you can bypass the kernel and talk port to port. Emulex is doing something similar to this. So whether it's worth the cost, I don't know. The Intel company they're always talking about is 6Win. So if you're interested in squeezing out as much possible performance without having to interact with the physical host. So when I talk about the physical host, or the host OS, that's basically, you've got one host OS that's running the hypervisor that is managing the virtual machine manager, which has all the VMs inside of it. So if you had a Windows machine running Microsoft Hyper-V, it's running this application that's managing all of these VMs that you spin up in Linux. is KVM. Containers is kind of interesting because it's not a fully virtualized or pair virtualized. It's more of an application virtualization. And so get to the next one here. There we go. So the interesting thing, so server virtualization, great. We understand that a VM gets a port just like a VM gets a port. Just like a physical server gets a port today, VMs get one or more ports. So how do we plumb all these things together? So Nicira, who was picked up by VMware in an acquisition, what they've done, and it pretty much has set the trend for the industry, is set up tunnels over the native network. So you've got your core routers and switches. You've got your edge or leaf top of rack switches. Those all run whatever protocols you want them to. So if you want to have flat fabrics, one big VLAN, or if you want to set up BGP between your core and top of rack, whatever you want, as long as that server on the end can set up a tunnel from it to the hypervisor vSwitch to wherever it needs to go. So it just needs IP connectivity, and then it'll encapsulate those packets in between. So IP mobility, vMotion, all these reasons that we need VLAN layer 2 extension, you can now do that because it's being extracted out into an overlay. So as you can see in this drawing, there might be the internet in between the physical host A and the physical host B, but when the server from the VM standpoint, it looks like it's directly connected and everybody's connected to the same VLAN. So the important thing is the network is now nothing is not used for anything other than getting from edge to edge or hypervisor to hypervisor. So it just sets up this point-to-point tunnel. Now, when we take the OpenFlow into account with it, what that's basically saying is, because that's actually how Nicira does on the edge, is because flow-based services, flow-based forwarding services are how you're going to instantiate firewall rules, how you're going to do load balancing and whatever. So the Open vSwitch specifically does flow switching. So if you look at it and using data path control tool, you're going to see exact match flows. So however many tuples, probably 12, and it's going to say here is what the exact flow is, and then here is an action to it. So maybe just normal, like by default it's normal, or it could be sending unknown traffic to a particular server, or in the model of what we're looking at here, regardless of how it's dealing with unknown traffic, it's sending destination traffic to a tunnel. So instead of saying match XYZ and then send it out port 5, it's going to say match XYZ and send it out GRE key 20 or tunnel, VXLAN tunnel 30. So instead of sending out physical ports, it's just going to send it out a tunnel. So what that does is you don't have to now worry about stitching that control all the way through the network. So each box or each hop along the way, you don't have to do, let's say, an OpenFlow lookup in the case of OpenFlow, or you're not putting it onto a network that isn't going to be able to get you layer 2 connectivity across the network, across the data center, or from data center A to data center B. So it's pretty heady conceptually, but I think getting in and learning kind of the core component, which is the data plane switch, starts to make it a lot clearer. So in the next section, we'll be setting that up. So thanks, and I'll see you in the lab.